Okay, and then we should see everybody start to funnel in here.
Hey, Mike, can I share my slide one more time?
Yep.
And then I'll stop. I just want to make sure it's still working. Can you see it? Okay.
Yep.
Okay, great. I'll stop sharing now. Okay, good. All right.
Go ahead,
Cool.
Kyle. You can leave that up while everybody's still joining.
Okay.
We'll give a couple minutes here and a couple minutes after 2 to give everybody a few to hop on. Hello, everybody. Thanks for joining. We're going to get started here in a minute. So just give us a sec. We're going to give everybody a couple minutes to get loaded in here and we'll get going. All right, so we still have a few popping in. One more minute, and then we'll get started. All right, let's get started. Welcome and thank you for joining CTI Connect in Toronto for part 2 of our 4-part Wireside chat series, The Road to WISPApalooza. Part 2, we're going to go over how Toronto's interference cancellation can enhance your network, how you can achieve superior spectral efficiency, and how you can rethink your network design with Toronto's G1 platform. Parts 3 and 4, ROI and scalability, will be held at the WISPApalooza Masters Monday on October 3rd in Paris Hotel, Las Vegas. These are a portion of an afternoon event when we will take a deep dive into the secret sauce that makes Toronto G1 a true next generation platform. You'll receive an invitation for this event following this Wireside chat. Don't forget to stop by our booths 145 and 149 at WISPApalooza. Please use the Q&A section for any questions during the webinar, and we will answer them upon completion. Joining us today, we have Kyle Friedis, Distribution Channel Manager, and Mo Williams, Senior Manager of Technical Marketing with Toronto. Thank you both for taking the time to speak with us today. I'll pass the screen to you for the presentation.
Thanks a lot, Mike. I appreciate everybody's time today. I know everybody has busy schedules, but I hope this is very informative for you. And the focus is on the G1 product. There's a question out there about G2. We're not talking about G2 today, just G1. So just a quick background for everybody. The product contains the base node, and the base node is what goes on the tower. Those are the radios you see in the middle of your screen. And then to the left of it are the remote nodes, or the residential nodes. And those are the radios that go on the side of homes or businesses that of course connect to the base node. To the far right is the Toronto Cloud Suite, and that's how you manage the radios. So the full solution are the radios, of course, the accessories, and the ability to manage and support all that infrastructure in the field with the TCS, Toronto Cloud Suite. So we're going to talk about a few things that you see on the left. We're going to talk about reuse of spectrum, K equals 1. We'll talk a little bit about the fundamentals of the products and how they work. And then we'll also talk about how you can rethink your network with those capabilities. So some of the things we're going to hit today is noise cancellation, multipath, future proofing, frequency reuse of 1, efficient deployments, long-range connections, and compatibility with other operators. Okay, first off, we need to level set a little bit. Clear line of sight means there's no obstructions in the Fresnel zone. So the radios can link without any obstructions, either moving obstructions or permanent static obstructions in the path. Near line of sight is when there's objects in the path that obstruct part of the Fresnel zone, but is not a complete obstruction between the radios. And then non-line of sight is when the radios, if you were optically looking at them, you couldn't see the other side, you couldn't see the other radio because there's something obviously in front of them that's permanent, it's not moving, and it's pretty big to obstruct the full Fresnel zone, okay? Now, Tarana can deal with all 3 of these, and we'll talk about these as we move through the discussion. One of the ways we're able to deal with obstructions in the field between the 2 radios is with reflection, actually bouncing the signal off of hard surfaces and allowing it to be sent or with a different path, a multipath, to the remote node or the base node, whichever direction it's flowing in. And it can be reconstructed, and it can be reconstructed extremely well to provide a very, very good connection that allows for non-line of sight or near line of sight. We can also deal with diffraction, which is the ability of radio waves to curve around objects. And here again, we can reconstitute the signal on the other side. The benefit of the Tarana radios is we're optimizing the signal on both sides, on the base node that goes on the tower and the residential remote node that goes on the homeowner, resident, or the businesses. By reassembling these multipath radio waves and all the energy, it provides a really, really strong signal that we can take advantage of these multipath that we're going around or over or reflecting off of different objects. So we're able to do beamforming, and with the beamforming, we can do it on both ends, on the remote side, the RN side, and the base node side. And because the environment may change because of movable objects or seasonal activities with the trees regaining their leaves and things like weather affecting, the leaf structure and what's on the leaves and all those kind of things, it changes the path. And because of that, we're able to make adaptation of the environment. And we're sensing 5,000 times a second to optimize the signal path based upon the current environment. So we're constantly sensing and sampling the environment between the base node and the remote node and optimizing the best path for the best signal to provide the best connection. So on the left-hand side, you can see where you can't see the radios. If you're on one side, you couldn't see the other side. You're going through foliage, maybe there's objects like buildings or what have you. And in the middle, there's some near line of sight issues, some foliage that you can see the radios, but there's obstructions between the two. And of course, on the right is a long shot, 11.5 kilometer shot in which you have clear line of sight. So we can handle all 3 environments. Now, noise cancellation, we're able to do with 2 things. One is beamforming. So we're actually able to shape the beam and direct the energy where we need it to go to connect to the RNs. The other thing is we have technology called ABIC, Adaptive Burst Interference Cancellation. And with that, we're able to cancel the noise that's in the environment that we're trying to operate. And so we're able, with beamforming, to direct the energy where we need it to go, and also to put in nulls where we don't want to receive interference energy from a competing provider or somebody else that's operating in the area. And then with ABIC, we're able to provide a connection in a really, really noisy environment where you have bursty interference that is going on, okay? So here's an example of multipath and beamforming. So we're able to direct the energy where it needs to go based upon the best path, the multipath, where it's going to be able to connect to that remote node. And here again, we can deal with moving objects such as the yellow bus in the middle of the picture there, whereas you know, at one point, the best path is maybe the left side of those three beams that are going across the bus. But as the bus moves through that field, obviously that beam is not as good anymore, and then it'll change to a different path. So that's part of the benefits of having beamforming and being able to manage multipath signals and reconstruct the best signal at the house where it's ricocheted off of multiple objects such as other homes in order to connect to the customer that has the RN on the side of the house. Okay, so this enables us to do non-line of sight and near line of sight connections to customers that are normally not able to be connected to a tower because they required in the past with other technologies line of sight, but we can handle that. Okay, so here's some examples of high bandwidth customers that are connected, even though they have obstructions, non-line of sight, near line of sight issues. On the left-hand side, this is a customer down in Texas, Resound Networks. In this example, they have one BN, so they have one 90-degree sector base node on a tower. They're connecting over 130 RNs in that 90-degree sector, and 91% of those customers that they can connect and address and provide service to are able to be provided over 400 megabits of download speed. And this is a 5 gig solution here. Some of those links go out to about 4.4 kilometers from the base node. In the example on the right, this is WISPAR, and they're out of Missouri, but they have services in 4 other states. 82% of the links can do 400 meg or better on the download. And this is an example where they have some long connections. This one's the furthest one in this example off of one base node is 18.4 kilometers. So as you can see by this example, these examples, you can deal with dense customers in one sector. So that's one radio on a tower, and they're able to connect with customers that have non-line of sight issues, near line of sight issues, and long range distance connection requirements as well. Okay, moving on. This is an example of CBRS, the 3 gigahertz product. And this is just an example in one location off the same tower in the same direction. What kind of comparative opportunities can you connect customers? So on the left-hand side, Tirana with our CBRS 3 gig solution, and you can see the red. If you look at the legend on the right, you can see that the red areas, they can provide, you know, better connectivity, higher performance, and then as you go further away from the tower, you can still provide connections and provide services 100 megabits, maybe address more customers, provide better coverage and higher customer speeds, longer range, and more customers connected. So that's what this is all explaining to you. So with that, you need to start thinking about how you would deploy this product differently and how you can save costs by engineering it differently and supporting clients where you could never support them or provide services in the past. This is an example of a single 90-degree base node on a tower in San Jose. And as you know, or you probably know, is that it's a really, really noisy environment. And this example, the service provider was able to provide really high speed connections. You can see the red and the orange is 650 meg, 500 meg, and even into the dark blue and the purple, they can still provide 100 megabit or 50 megabit services, download speeds. They can provide longer range connections. You can see the curve, the blue line out to 15 kilometers. You can connect a lot of customers, and this is all from one sector on one tower. So think if you added more tower perspectives and did a 360-degree coverage on that tower, that's a lot of customers. Every sector we can provide coverage for up to 254 customers per sector. So think about 1,000 customers can be serviced off of one tower with 4 base nodes. Okay, so dense coverage. We can handle coverage in a metro area or a rural area, and the minimum inter-site distance is about 400 meters. Now, there's some things you have to consider with that design and that topology, but essentially that's a good general guidance for the shortest distance that you could have towers where we're operating. But because of beamforming and nulling and all the other things that we provide, we can operate in this environment and not interfere with ourselves. And that's the example on the right-hand side, where we can reuse the spectrum and interoperate with other providers or a single provider in an area where normally they'd be interfering because the radios are pointing in the same similar direction. So this allows you a denser cell coverage solution if needed, and it allows you to operate in areas where other Toronto radios are operating currently or in the future. So with the ability to manage heavy interference, you should rethink your network design. Every tower, every sector on that tower can now be considered for base nodes. The towers that overlap coverage to connect customers should be considered, right? So you can have coverage from different directions or provide more connectivity to customers in that area. So if you had a sector that needed more than 250 customers, you could provide that solution for 300, 400, 500 plus customers. Customers can be connected where, in the past it wasn't feasible because of non-line of sight, near line of sight issues, and we can address those now. And also consider longer range distances off some of your existing towers or maybe other towers that provides you better coverage to the edge of your service offering area in your different regions that you provide support. A couple of case studies. The first one is Resound. So they had the ability to deploy fixed wireless in the southeast of Texas. You can see their area of coverage down there: San Antonio, Austin, Houston, and Corpus Christi. And what they found is they had a 40% reduction in the number of towers required for full coverage in their area. They also found that there was 50% reduction in installation complexity and time per tower, meaning the number of radios that they had to put up on the tower was either 3 or 4 base nodes, and that was a reduction in just total time, effort, cost to do all those installations. They saw a 50% reduction in overall deployment schedule. So as they pushed out into those regions and lit up those towers and then deployed into the residential areas, they were saving an enormous amount of time, half the time that they had planned on doing their rollouts and their service introductions into greenfields, new markets. They saw greater than 3 times real world end subscriber speeds and supporting up to 1 gigabit plans for some of the customers. What we recommend is that advertising 600 meg plus, but certainly customers can get higher than 600 megs. They had a rapid full-scale marketing effort into these large suburban areas, and it was possible because they knew they could address that market with pre-planning with the Google Network Planner that is available for everybody to use. They were able to figure out which markets they could cover and which neighborhoods and the addresses and complement that with their marketing initiatives. And it's just a substantial reduction in network maintenance and customer support that was required in these areas that they delivered Toronto. Here's an example of a side-by-side comparison. It's a generic but a real example. So if you had the requirement to provide 1,600 subscribers in a 20 square kilometer area, and you needed about 200 subscribers per sector at a minimum of 100 download, 200 meg upload service, what would it take for the towers? So with the Toronto example, you could do 2 towers, 4 sectors per tower, okay? And you could offer plans that were above 500 megabits if you wanted, with download speeds and then upload speeds over 100 megabits if that's what was required with the service offering of this service provider. The alternative is the number of subscribers per sector is probably closer to 40 or less, and the number of towers required to cover the same geographical area and provide at least 100 by 220 megabit service was greater than 10 towers required for the same coverage in that area. So that's, you're starting to understand the differences, hopefully, between what's required in the base nodes and what goes on the tower. But with that, you can have a much denser deployment of customers that can be serviced off of those fewer towers. Okay, here's a quick example of the economics of 3 different environments. The urban is on the left, suburban in the middle, and the rural on the right. And you can, the household densities, you can see 2,000 per square kilometer in the metro areas, 800 in the suburban areas, and 30 in the rural areas. The spectrum is either 5 or CBRS, 5 and 6 gig, or CBRS, I should say. And you can see the number of households passed that can be covered by that deployment. The cost for household pass, $4, $5, and $10 respectively. And the target penetration was to get up to 10% coverage of customers in that area that would take the service. And in the case of the suburban, up to 25%, in the rural, 50%. And with that would be different packages that would be provided in the suburban urban environment, like $50 packages, and then rural would be $70 or more. The internal rate of return, as you can see at the bottom, is greater than 80% for these different solutions and these different business models. So hopefully this gives you an idea of that you can cover, suburban areas where there's a lot of homes, but there's obstructions near line of sight, not a lot of sight issues. And certainly in the urban areas, you have a lot of customers, but you can take advantage of that multipath and provide good service in an area that just cannot be served with other technologies today. Okay, this example, just the blue line is the Toronto and the bottom gray line is fiber. So if you can get fiber, great, right? But the challenges are the time it takes for it to get trenched and deployed and lit up and connected and all those kind of things just takes a while. So with service providers that realize, having a mix is great, having a hybrid network, of course, with fiber and fixed wireless is very beneficial. But the big advantage you have is that you can deploy the fixed wireless much faster and gain revenue much quicker. And therefore it helps with, the financials of your company and the fact that you can service customers and, retain those customers in your geographical area and not have somebody overbuild on top of you. In the meantime, while you're waiting for fiber, great, you have revenue. It's a fungible asset. You can relocate the Toronto products if you so deem in the future, but realize you can provide the same performance and speeds over time because Toronto can be upgraded with software to increase the port speeds of the remote nodes that are attached to the residential sites. Okay, so given that, with the ability to use fewer base stations, it reduces, the the cost on the tower and what you have to build on the tower. And then you should start thinking strategically about which towers I would select in order to provide the best overlay and provide the best performance in order to provide the best service offering and the highest ARPU for those packages, like 100 megabit service or 400 megabit service for businesses or whatever that is. So with network planning, it provides a more flexible and scalable solution. And with that, you should rethink the design and how to deploy. Now, our sales engineers and our team can help with this. We can show you how to do it. The good thing about CTI is they have a technical accredited trainer on their staff, just like Mo Williams is on our team. And they can help you with the design work and trying to figure out the best planning before you actually make purchases. Now, the other aspect of the Toronto product, we talked about this briefly, is just that you can increase the port speeds on the remote nodes. They are shipped at 50 megabits per second, and you can upgrade them to 100, 200, or 600 plus megabits. Now, these radios will go up to 800, but what we provide and what we encourage and what we state is that the upgrade will do at least 600 based upon performance of the link in that specific area. But you will know what the radios can do in that area, because when you turn them on, you can actually do the speed test and figure out what's available. So it should match your Google network planning that you had done prior to deployment. Okay, so how do you rethink that component into it? Fewer radios on the tower, less radio maintenance, less leasing costs to install and maintain radios on the towers, fewer people to manage the spectrum, because you're not going to deal with interference issues where you're knocking each other out or knocking your own network out with interference. You can think differently and plan differently. The longer life cycle of the RNs is based upon your ability to upgrade those remote nodes with software to increase performance and therefore reduce the number of truck rolls to customers. The higher density of customers in those sectors off that base node means the concentration of field support, meaning you can cover that area with a lot more customers that can be provided the service, and therefore you can support it in a much more dense area with your field technicians. The higher revenue per tower, of course, too, because you have more customers working connected to that base node. So deploying Toronto is faster than connecting fiber to the homes. It's the fastest path to revenue with fiber-like service offerings to your clients. And of course, you can grow those over time. So we talked about a few of these things today. I think we covered them all, actually. We talked about noise cancellation with the ability to do beamforming on the base node and the residential node. You optimize the connections to deal with non-line of sight, near line of sight. We actually create nulls in the beams to reduce energy where we don't want to transmit it. So we aren't polluting the spectrum where we're not going to connect to a remote node. And also we're not going to listen in that area either. So by doing so, we're able to cancel out the noise. And with adaptive burst interference canceller, ABIC, we can improve performance too, where other radios just can't deal with the interference. Multipath, here again, we're bouncing signals off of solid surfaces to operate in that NLS and non-line of sight, near line of sight environments, future proofing with the software updates, so the performance, the speeds, frequency reuse of one with full order modulation allows us, deployments across many towers where we won't interfere with ourselves. So a service provider won't interfere with themselves and their own radios, and then won't interfere with others that are operating on those towers too. Efficient deployment, high density customer delivery, here again, up to 1,000 customers off a single tower with 4 base nodes on that tower. We can support longer range connections, as we talked about earlier, 7 miles for customer connections, line of sight, 2 to 3 miles for near line of sight customers. It depends on terrain and the obstacles that are in the way. And here again, we're compatible with other operators. So we have radios that are working on towers that other providers didn't realize that our customers, our service providers, had actually lit off the radios and they're operating, and they didn't realize that they were, because we weren't interfering with others. So that's another benefit of being able to coexist and not create problems when it's deployed. So here's the look of the remote nodes on the left-hand side, and the base nodes, of course, in the center there. And we talked about all these pieces and features and capabilities, and just these are the things you want to consider when you're rethinking your network design and planning how you're going to deploy, and also think about the marketing effort and identifying which of the best neighborhoods and best cell towers to operate off of, or water tanks, or structures that you can emanate off of a building to provide the best service for the highest density number of customers that are willing to pay the most for these packages that you would offer. Okay. All right, we're at questions. So we're going to go to QA now. All right. Okay. So for the dense coverage example, is that showing the same frequency channel? Yes, it is for the base nodes. Do those costs labeled as cost per household include support costs, or is that just the hardware cost? It's the hardware cost, and it's based upon some nominal installation fees. And I don't know the exact number that we used in those models. What Mike Hopperidge talked about is on Monday at WISPApalooza, between 1 and 5 o'clock, there's the CTI symposium. We're going to go through the business case model, which is a spreadsheet with some assumptions and slideware as well. But we will share with you that cost model and that cost structure that we came up with all those numbers. So if you're able to attend WISPApalooza on Monday in the afternoon in the Bronze 1 room, we will go through all that in detail. And then we'll certainly sit down with you and go through it in more detail if that's what's needed. Okay. Why do you use this model for subscription? Why don't you just give us the units opened up? Okay. So the differentiation of the port speed upgrade is that you can allow your customers to have a differentiated model, right? Adding more value to your clients where it makes a lot of sense. To be quite frank, the remote nodes, there's not a lot of margin in it for us right now, making RNs. And this is a way that we can provide the least expensive base model of the RN for those that are fine with 50 megabits. In time, we hope to reduce the cost of our RNs and improve our margins, but we're not even close there yet. So that's the reason for that. Okay, let's see. Okay, if you buy a license for 100 megabits and need to change that to 600, it basically you would pay for the upgrade from 50 to 100, okay? And then if you're going to go from the 100 up to 600, you would pay for that additional amount to go up to 600. If it met on the annual fee or the 3-year fee, of course, then you just pay for that 50 to 600 meg upgrade. The discounts that you need to talk to CTI about, because the discounts are related to volume purchases and things like that. So you really need to talk pricing with CTI as far as discounting and things like that.
And we can help you price anything out you need. We can get you to a sales rep if you don't already have one. So yeah, absolutely. Just let us know if you want a quote. We can get that to you right away.
Yeah. Do you know the number of years using the IRR for the 80%? I do not know, but I believe it was 7 years. But here again, when we peel apart the business model on Monday at WISPApalooza, we'll have all the assumptions associated with those as well. Okay. The question was, can you provide a ballpark on the support cost per model? As far as, I'm not sure what that means, if that means installation support and then follow-on support. Usually these radios, the RNs, assuming that no structure has to be installed at the client's house, meaning there's no tower or no structure that goes on a roof or anything like that, assuming it attaches to some part of the house, then the installation costs are usually max 2 hours on site, and that's start to finish. If there's structure required, that's a lot more. Let's just be frank. And then after that, there's no reason to roll a truck as long as the equipment is not damaged due to natural causes or some weird thing. And then there is an annual software maintenance support license that's an annual fee, and that goes with the radios, and it depends on the number of years you buy upfront and all that kind of stuff. Here again, CTI can quote all that for you.
Yeah, and the SMS keys, as Kyle's referring to, they are for the use of TCS. So that's your mobile web-based NMS system, your platform where you can do your upgrades from, and you can get a look at where all your RNs are, how they're performing, how your BNs are performing. So that fee is really an NMS fee if you want to think about it in terms of what you're paying for. That's what that service fee is. And honestly, you get quite a lot for the nominal fee.
Yeah. Okay. Mo, have a question for you. What is the maximum distance for an RN to connect to a BN? So can you talk about?
I started to type the answer to that, but actually there were a few kind of things that I wanted to touch on. So first of all, there's a parameter called network profile that can be set on it can be set globally for your network, and then you can do it on a per site basis. You want to make sure that that parameter, the network profile, is the same for all BNs and sectors that can hear each other, because that sets the TDD timing. And right now, the profiles, mostly what that changes, the 3 profiles that we support, is the ratio of downlink to uplink. But it also sets the maximum distance, the maximum distance from an RN to its BN is 15 kilometers. We do have another network profile that is being trialed live that will extend that. But it's mostly important that you have all of your BNs that can hear each other be at the same time, so be on the same setting so that you're not stepping on each other with your timing.
Oh.
And if that didn't help, then you can email me at mo@Toronto Wireless, and I will get you a better answer.
Okay, thanks, Mo. Do we have to re-up the port speed subscription so once we buy it, it's not ours? The answer is yes, you have to have a continual subscription for the port speeds if you're going to have something more than 50 megabits, and you can buy it in 1, 3, and 5 year terms. In the side-by-side comparison, where we compared 1,600 subs with speeds of 500 by 110, is that the speed all subs can get, or just a percentage? It actually varies, right? Because you have different customers that can achieve higher performance based upon connectivity issues, non-line of sight, near line of sight, what have you, and distance and whatever. So it's not, we're actually able to provide higher performance to more customers in those examples. But what we wanted to do was provide at least coverage for 100 megabits download and 20 megabits upload minimum for those customers. That was the comparison one for one. But what we can do is provide higher speeds. And yes, a lot of the customers, it was a mix of 100, 200, probably 400, 500 meg and higher was the Toronto side of it. Okay, what happens to the BNs and RNs if they no longer pay for support? So if you do not continue your SMS license, You'll get notification and warning. Will they continue to operate? Yes, they will continue to operate, but they'll be downgraded in speed until you can clear, that you have a license and you're going to continue to operate. It's pretty, the licenses are pretty inexpensive. And here again, CTI resells those. Do the radios have GPS? Yes, they do.
No, they don't.
On the BNs.
The question is for the RN.
Oh, I'm
Does
sorry.
The RN have a GPS.
Okay, I stand corrected. Thanks, Mo.
Yeah, so on the RN, when you do the installation, you will provision the latitude, longitude, height, azimuth, and tilt on the RN. And as the next question down about the CPI, that's very important, of course, on the CBRS units.
Okay, go ahead. Why don't you answer that, Mo, and I'll jump back to the other one.
Actually, I'm going to need a clarification about what CPI remote signing is, because this is everything's remote. You're logged into the web UI and the and TCS. So when the CPI installs the RN, the parameters are configured through the web UI, and the CPI installs his certificate or uploads his certificate information on that, and then through TCS, that part actually is already done through TCS. So and so at the time that the RN gets configured,
okay,
hang on, I'm walking my way. I'm walking my way through that one. So I'm guessing that that app that's coming out is going to answer that question. The phone app for configuration.
Yes.
Okay, Alex, I have completely mangled the answer that you were looking for. So once again, ping me at Mo at Toronto Wireless so that I have your contact information. I will get you the answer that you deserved. I apologize.
Yeah. Okay. Are the support fees based upon a flat rate or number of subs? It's based upon the number of RNs you have in the field. So you need the SMS license to have coverage for all your remote nodes out there. And the SMS license is only for your remote nodes. Now, what do you get with that? You get access to TCS, the Toronto Cloud Suite, where you manage all the equipment, you have all the alarms, you can see all the performance, and of course you can do all the provisioning there. The next is you get access to all the upgrades, the software upgrades for all the radios that you have deployed. The other part of it is 24/7 support, that you will get a hold of a technical person that, one, can either answer the question, number two, assign a ticket and escalate it if they aren't able to resolve it. So if there's major outages, we're going to stay on the phone with you, work through the issues. And of course, you get access to the back office engineers if it's a really challenging problem we've never seen before. So that's all part of the SMS license that's included in that. And that's here again, just for the remote nodes. Okay. All right.
I think we have time for one more.
Yeah, Alex had a follow-on piece of that, Mo. So maybe send the reply back. Okay.
I'm doing that right now.
Okay, great. All right. Okay. Does support include assistance for BDC filings? Mo, do you have the answer for that one?
That's a really good question. I know that we do help with RFPs. BDC, I do not know the answer to that. Mm-hmm. But once again, Mr. Anonymous, I am Mo, and if you, I will follow up with you if you send me an email.
Or if you're going to provide your contact information in the Q&A, we can get back to you with that.
Okay, Mike, thanks so much.
Great. Well, we appreciate everybody's time. Thank you, Kyle and Mo. And, don't forget, if you're going to be at WISPA, to stop by our booths, 145 and 149. And everybody on this webinar and anyone who was on the previous webinar will get an invitation to the Monday event that really goes over ROI, and Transector will be there to go over best practices for DC and POE surge protection, as well as a finance partner, Stefan of Capital, to talk about building your network better with Toronto. So again, thanks everyone, and we'll see you at WISPApalooza.